It is my privilege to introduce Dr. Pu. Most of you already know her as a full professor in our department with a great deal of expertise in numerical weather modeling. So just to give you a bit of background, so she did her PhD. We'll just won't say what year, unless you want me to. You and I are about the same age. She did her PhD in 1997, and then she went on to be a visiting scientist at UCAR. She also was a postdoctoral fellow at UCAR. When I became aware of her work was when she was at Goddard, and that was in the early 2000s. She then became an associate research scientist at Goddard and moved her way up to assistant professor, associate professor, and a full professor here at the University of Utah. I've had the privilege of working with her on the CFAT campaign, which is the Cold Fog Amongst Complex Terrain campaign. And I'm really happy to say that her overview paper was published in BAMS yesterday. So everyone can see that paper.
Okay, thank you, Gannett. Yeah, good afternoon, everyone. Yeah, it's my pleasure to give a seminar after this non-pandemic. So having a talk to the department for a while. Yeah, this is my 20th year in the department. So definitely it's my 30th year working in the United States. And I came here as a PhD student, work at National Centers for Environmental Prediction for the Environmental Modeling Center to finish my PhD work, use NSAP operational model, and I did a target weather observation by the time. And then I moved to NASA Goddard Space Flight Center, worked 5 years for the satellite data simulation, emphasize on the trim satellite data on the hurricane study. And then I moved to university as a teaching position, which was my dream during my early year, and I wanted to be professor, and eventually in US, I became a professor. So I'm here, so this is my 20th year, and I'm glad to be here to went through all these promotions. And so then, yeah, so establish my research program and a group, work with so many wonderful people. So for today's seminar, I'm not going to talk about my own research, talk about the report for on the priorities of US weather research. So why I brought this up is because this is very important nationwide. For the NOAA is the national agency who make the daily US forecast and from the short range to mid range to S2S, and also season, interannual, even the climate prediction. So these nations has the wishes to improve all these forecasts, and all the industry and people living in the country, they need an accurate forecast. So then this priority for the weather research definitely is closely associated with this. And I'd like to bring this up for the young generation, as most of you sit here as a young graduate student, because your research, your work will contribute to this area. So in this talk, I'm going to just talk about some of the background about why we should bring up this report, and why people should work on this, and also the process to have this report, and also the report structure and the summary, and talk about some of the immediate first steps. So this is what the community will be emphasized, and also some of the future engagement, and also offer some summary and discussion. So this power study, so a priority of weather research, begin with the Congress discussion, because Congress makes a charge to the NOAA to write a report to guide the nation's investment for the weather research, and which means a request to put some priority for the investment. So Congress put this task forward to NOAA, and NOAA charged the NOAA Science Advisory Board to work on this. And fortunately, by the time I was appointed as a member of NOAA Science Advisory Board, so this just began. So I was immediately included in the team to work on this power study. And so we call the power because it's a priority of weather research. So it's standard for that. So NOAA Science Advisory Board is a team of the people from the academic, from industry, and also from the private sector, and all come together to give the NOAA administrator. So we are kind of like cabinet of the NOAA administrator, and so just to help the administrator to make the define of the NOAA application, research, science, and also education, and all this define all these priorities. So then the first thing when this task comes through NOAA Science Advisory Board should take this charge. So why the Congress raised this issue and ask for this, and also why NOAA kind of like get very serious with this, because all these things escalating by the demanding for the accurate and the actionable weather information. So this is a diagram showing the US 2021 $1 billion weather and climate disaster. So which means, so each year this weather and climate associated disaster costs $1 billion. And then you can see some of the keywords here. So this is drought and wildfire, and also some of the this California flooding. So this even last year and this year, so in the transition, we also see this happens. And also some of this winter storm event, and Texas and Oklahoma severe weather, and the hailstorm, and hurricane, and flooding, and also tornado, and some of this Easter severe weather event, and the southeast tornado and the severe weather, and all of this you hear from the news. And we heard this happened, and we continue heard this, and this is caused a lot of the damage and the economy impact, and also the social impact as well. So this is, there are increased trend about this type of the weather-related damage. So this is the number of the event. So the green here is yearly number. So what happened from 1980 to the year 2020. And then blue shows the 3-year average event. So you can see there is an increased trend of this type of the event and also the damage. So IBM did a study, and they used the literature and the report in the past 15 years, and they want just to see what is the impact of the weather to the business globally. So as you can see, so there are some positive impact and negative impact, but you can see there are significant negative impact here. So weather forecasting are used daily in business decision, and they support food, water, energy, and the national security, as well as economy. And so all the information here, from not only from the NOAA or from the government to announce the forecast. There are many people use this forecast. There are real social economy and even the interpersonal, the societal community, all this influence. So it really related to the most of the business decision now. And so that's why Congress becomes want to be invest on the weather research, and in the meantime want to have this priority of the research. So then the purpose of this study to generate the research, this report is definitely evaluate and provide the information necessary to prioritize the potential government investment in our requirement-based framework to advance the United States weather research and forecasting capability over the next decade, but definitely move forward as well. So then after get this task, so NOAA Science Advisory Board start to organize a team work on this. So they set up a framework and they have the team from the steering team from the Science Advisory Board leadership, and they have executive study team work with NOAA. So I joined this team. So we actually, this is led by Brad Coleman, so who's current president of EMS, and he and Scott Glenn, so this is a professor majored in oceanography from the Rutgers University. So then lead this team is whole team to decide what's the action item for the whole team. And then there are some work group team. And so this working group team corresponding to each of these planners and determined. And so then, so with the many people in the team, so we have many of the expertise in the team with 150 people. And also you can see this executive study team include Marshall Sheffield and also other leaders from the industry and from the US Air Force and also the US Navy previous leader. And so they all contribute to this. And then, so eventually hold many of these more than 100 meetings. So by the year 2001, so at the time we are in the pandemic and stay home. So people spend a lot of time on the Zoom meeting. And there were Zoom meeting at least 2 or 3 each week for the a year. And so not every group meet every week, but I think as an executive study team, we meet once every other week, so 2-week meeting. And all other team also had a mini workshop. So you can see about 159 people involved. So NOAA has 62 and the other area have 58. And also there are included this team, 39 people. So there are many people, and also there are many people invited to give talk during the meeting. So first thing, talk about this framework of this pulse study. This is the whole thing about the first thing is it has foundation element. So it's whether enterprise, working force development, computing, and science. So these are you see, this is just like from the foundation, when you build the house, this is the things to kind of like the map your house be standard. And so these pillars of the weather enterprise include observations and the data assimilation, forecasting, and the information delivery. And on top of this is lives, economy, and equity. So then there are requirement and the evaluation feedback and the weather information pipeline. So all of these things together. So these are all the elements we should be considered. And these 3 are the working group taken care of. So then I will give some of the background just outside of this report. And so for you to understand why we should have these 3 things as the center of the study. So as we all know, so these nations forecasters start with NOAA's supercomputer running the NOAA's model in Washington, DC. So each day, what it happens is NOAA operates the computer model and then produce the forecaster and also give all the information online, and then everybody starts their own individual forecast. So this whole nation's forecast start. There was discussion maybe like 15 years ago when the Weather Channel began the business. People would say, we have weather channel. Why we need NOAA? So just cut them. So NOAA actually at the time then made an argument in each of their presentations say, so NOAA, National Centers for Environmental Prediction, where the nation's forecast starts. So this is starting point for everybody. Okay, so then this is from my class notes when I teach the NWP class. So this is numerical prediction. So now we call the Earth system modeling and the prediction. So for the atmospheric, this depends on what your model is. If you use the atmospheric model, this is the atmospheric prediction. But if you use Earth system modeling, so this can be the prediction of the weather, climate, and also Earth system. So what this begins from the bottom. We have observation. We NOAA built this observation network. We also have satellite mission and all this observation. And this observation through the data assimilation to make the initial and the boundary condition for the numerical model. And we into the numerical model and then produce a forecast. So we have this forecast, and then people can use this forecast to interpret or just generate the forecast. So for as far as this numeric model, it has the dynamics describe all the motions, evolution, and you can use the numerical method. And also physics parameterization deal with the real physics like radiation, cloud macrophysics, and all these, but also deal with subscale processes. So what's meaning the subscale processes? We know, so for instance, for the atmosphere, so we have all scale of the motion. So in terms of the time and the spatial scale, so you have turbulence, you have cumulus, and the cloud scale, and also you have the hurricane, tornado, and also deal with the front system, and also the trough and the ridges, and all kind of things. Even the climate change deal with 100 years and globally and those things. But our computer model always have its capability. So we call this is resolution, which means the grid points we made it at the certain time and the spatial scale. So for instance, if I use the 10 kilometer resolution global model, so then I cannot resolve anything smaller than that. So then I need to use this grid value to represent this subgrid scale contribution. So this is called the physics parameterization. So this is the numerical model. So that's we do start from observation data assimilation and then running the model to generate the forecast. So what's more? So even if we want to do the weather prediction or the climate prediction, so we see this is the Earth system. So include the atmosphere and the hydrosphere, biosphere, and the cryosphere, and also this. So this is the things we deal with, the mountains and the geographical things and all these. So these are all different sphere we needed to deal with, and also they have the interaction. So then in order to make the accurate weather climate prediction, we not only needed to deal with the atmosphere, so we needed to deal with land, sea ice, waves, ocean, and also the air chemistry. So the aerosol, carbon dioxide, and all of these things. So it's integrate the science for the Earth system modeling. So currently, so what my group we start work on the land atmosphere, coupled modeling and the data assimilation, and the other people in the department work on the ocean atmosphere coupling or sea ice coupling and all these things. So you heard a lot of this coupling, and also other people work on the air quality and all these things. It will be eventually all components contribute to Earth system modeling and the prediction. So everything's associated. So because of this, so now it's easy to understand. So why this pillars becomes observation and the data assimilation and the forecasting and also information delivery. So after we generate the forecast, we need to deliver the information into the public, let them to make their own product. So then these three are the key things to make the area for the this power study to generate the recommendation. So then each this priority area contains multiple recommendations, and each recommendation contains multiple critical actions. So this is not just a report to make recommendation, but also make the recommendation to take the actions.
Sasha, I didn't see the, or I didn't remember in the outline. Are you going to tell us what those critical actions and recommendations are?
Yeah, so it will come up. Thank you. Okay, so then after, as I said, and like these so many people work together, and after about 9 months, so eventually the first draft of this report published online. So this is available online. If you want to search, you can search this 96-page report, have everything. And this draft was approved immediately. But this is not the end. So after the December 2021 published this report, so this report has been continuously discussed in all level. And so it continuously included since. And recently, for all NOAA research announcement for the opportunity, they cite this report. So this report included a summary and also some of this introduction, extreme word, and this narrative themes and the panels, and also foundation elements, some of the steps. So it's kind of like a mix. Some enough background for people to understand where this recommendation come from, and what recommendation and what action needs to be required. So just to give some of the summary and the introduction about this. So this recommendation by the number of the theme for the observation and the data simulation, they have 3 priority area, and they give the 10 recommendation, and some of these critical action becomes 33. So it's from the high level to the detail. So it's all of this area becomes this. So then you can see this recommendation corresponding to this framework very well. So this area, this area, this area, and also foundation. So it makes all the recommendation here. So I can show you some of this recommendation, how this looks like. So first thing is, I think Peter asked a good question. So for observation and the data simulation, so it gives a priority area 1, so use and assimilate of existing observation. So we needed to maximum use of some of these ground-based airborne and marine observation, and also maximum use of satellite observation. And so then the priority area 2, advanced data simulation method. So to develop the establish new support of novel methodology research and working force development for data simulation. I will talk about this a little bit later. And then advanced coupled Earth system data simulation for weather, water, sub-seasonal to seasonal forecasting. And also advanced production of regional and global reanalysis. And so the observational gaps use and assimilation of the new observation. So there are listed some of the observation needs. So this is for the data simulation. And so then I can go back to say how this type of the recommendation has been generated. So this is actually based upon the first thing is from the 5 narrative theme from the weather-ready nations. So you can see the first one is global leadership in weather prediction as a pathway to high-quality products and service, high-impact weather. and so mission critical miles and highly reliable, fully accessible weather information, and improve prediction of water cycle extreme and the cascading impacts. So this is other themes from this weather ready nation. So this sets the whole requirement. And then the team reviewed the current status in terms of the nation's forecast scale. So this is the anomaly correlation coefficient of the 500 geopotential height, northern hemisphere. So this is the annual mean from the 1984 to 2020. So for the US CONUS domain. So as you can see, this is the forecaster, this 500 millibar geopotential height often to be the one of the key index to indicate forecast ski improvement. So this is showing the number from different sources. So you can see here, GFS is global forecast system, which managed by NOAA. So this is US national forecast. This is black line. And then, so the red is ECMWF. And so this green is kinetic, so Environment Canada, so the Kinetic Meteorological Center. So, and also compare with others. So as you can compare with the GFS, you can see there were significant improvement in the forecast scale for the GFS. It's continuing increasing. But in the meantime, we're not #1 in the world because ECMWF did far better than the GFS, so which is about 2 years lead. So then this is challenging. So we're not doing really leading the world for the forecast. Okay, so next things, high impact weather are challenging because we hear a lot of times. So then in terms of the high impact weather, we still see a lot of damage. We cannot be well prepared. And another thing is, if you look at this global forecast system annual mean equitable threshold score, some of the graduate students, when you're doing your research, you always calculate this ETS score to check the quantitative precipitation forecast. So you see this familiar, I'm sure. So you can see from year 2002 to year 2020. So this score gets nearly flat. So precipitation forecast is very challenging in the operational forecasting environment. So this is something we faced. So then based upon the this theme and what's the current status, so then all these priority area and the recommendation has been set because people want to know what we did well and what we should do. Okay, so in terms of the data assimilation, so in my class, I talk with students. So data assimilation is a methodology. We combine the observation and the short-range model forecast together to generate the best possible analysis to input into our model and to produce a better forecast. So definitely observation has error, model has error. The task of the data assimilation is we produce the analysis which better than either observation or the forecast can produce, and so get the best possible data for the as an input for the forecast model. But you can see the early days, we thought we mostly use the initial condition to improve the weather forecasting, which is mostly for the short range weather forecasting. But nowadays, so we need to develop the coupled Earth system data assimilation to kind of like improve the forecast, not for the short range weather forecasting, but also for the up to the S2S. So for this weather research, we do not do anything beyond the S2S, but so even for the S2S, subseasonal and seasonal still will require accurate initial and boundary condition to be specified. Okay, so just and also all these recommendations from the different area has a link stream. So this is for the forecast. So for the forecaster, so we do the fundamental Earth system modeling. So acceleration Earth system model develop and seamless prediction. So which means we do the multi-scale and the multi-component forecast. So at once. So nowadays we see a lot of this unified model, which actually fit to this purpose. And also achieve the best possible operational numeric weather prediction system. And establish a regular sustained Earth system forecasting activity. And so number 2 is advanced and critical forecast application. So the sub-item included enhanced prediction of Earth's water cycle extreme. So it is included the floods, droughts, and also the hydrological process. And then increase efforts to advance predictive capability for fire weather and air quality. So this has been also the highlighted fire weather, air quality. So NOAA recently has a lot of this research announcement in this area as well. And then they improve the forecast of high impact weather through multiple partnership. So high impact weather. And then advanced research on coastal process in Earth system model for comprehensive coastal analysis. So coastal region. Okay, so this is about the forecast. And then the information derivative. So this is something becomes very in the internet and the cloud computing and all these type of things now. So then this is the area we actually invite the many people outside of the academic and the NOAA to discuss because there are many users directly use weather prediction information to do the decision making. So then this is very important part. So first thing is highly reliable, high resolution weather information dissemination. So this include embrace open science to provide a uniform access to all community, support geographically distributed and diversity working force, and broaden access to tenants and increase agility and innovation. So the information to get more broad and open science, meaning in the future you will see a lot of open source software and open data. So complete the existing plan to address National Weather Service operation data dissemination challenge, and develop NOAA-wide strategic and operation support for weather enterprise data integration and dissemination. So I think after this one, last year, and so within the NOAA Science Advisory Board, we have a subgroup group people to work on another report on the NOAA open science, open data. So we have that recommendation published online as well. Okay, so then the second area is about the connecting and the analyze social behavior and the interdisciplinary observations. So prioritize research on the equitable and the effective use of this information about especially for the standards which can have the high society impact, and develop and evaluate probability and deterministic information delivery capability for diverse end user. So this one is, I think, more associated with the current use of the ensemble forecast. So if we open our app for the weather information, so in terms of rain, no rain, sometimes you see percentile. So which means 20 years ago from the AMS and the NOAA, So they began to encourage people to use ensemble forecast. So the use of ensemble forecast, so instead of give the forecast to the end user, in the meantime, we tell you the forecast is not accurate, and so what's the reliability of this forecast? So says, if it's raining, I tell you the probability 90% or 30%. So then you can use this probability to make your own decision depending on your level of tolerance for the risk. Okay, so this is continuous, I think it becomes one. And then building the capacity to collect and analyze baseline and event-specific social and behavior data. So this is something new. And I remember there are some social scientists were invited for this talk. And I think this is not only the time make the recommendation, so a lot of this Zoom meeting while people still work at home really kind of like get very broad attendance and the link, a lot of people begin to talk. So that's why after this report published, so all the discussion continues. Okay, so this is just give you a diagram about the weather information development, dissemination, and the evaluation research cycle. It's beginning with the decision maker. So we first define the weather product specification based on the decision maker's needs across decision content. And then you do your development with the weather information product. And then dissemination is you to kind of like make the information again to the decision making. And then you make the evaluation and feedback. Then you do research again, and then come back to here. So it's kind of like begin with a cycle. Okay, so I'm not going to go detail about this one, but the weather enterprise integration data and the information flow for all sectors. So you can see now, so there are very structured the use of the weather related information to support the decision making. So this is kind of like critical. So that's why the information dissemination becomes one of the very important thing. And lastly, so for the foundation element, so there are some recommendations here. So the first one is regarding to the science. So the develop weather knowledge ecosystem, and they continue invest in the understanding the basic physics and the chemistry of Earth system, and accelerate NOAA artificial intelligence. So they already have an AI center within the NOAA from last year. And then, so the increase the university involvement in NOAA research. So this is something good for us. And also create multiple university research consortium and to address critical research issue. I will talk about this already become true. And then the computing is one other thing, and the working force, which means to emphasize on the education and also training program, and also develop this vision for the working force education training, and then weather enterprise integration. So all these things, the foundation part, I think it's relevant. Many of this industry, academic, and also computer science, and also even the human resource type of things. But in terms of the working force, there are some also from this recommendation generate some of the report say that, so like say that there are shortage of the community for the data assimilation scientists. So this is not in this report. And then NOAA recently have a research announcement to build this multi-university data assimilation consortium. So there are some news come out and I can share with you. So then this is some of them talking for the immediate first step to take. So like the critical gaps and the shortfall, and also there are some temporal dependency and high readiness and high rewarding activity. And the core area include the research and development, infrastructure, action and impact. So this priority and the investment. So those are the things highlighted as the first step. So accelerate Earth system modeling approach and increase investment in social and human behavior data collection and science. Okay, so there are some people work on the social economy impact from the weather and climate. So this is definitely here. And fully implement and expand a rapidly existing plan for the improved weather data dissemination, expand the high performance computing capability by 2 orders of magnitude over 10 years. And then fill gap in existing Earth system observation network to see what is our observation gap. So with the existing proven or augmenting technology. And then the one thing is the immediate investment in fundamental research on data simulation. So as I said, the data simulation science combines observation and the model together. And for many purposes, it generates, helps accurate forecast and also analysis verification. So this has been highlighted. And then support reanalysis and reforecast to the Earth system model evaluation and the improvements. And they target the understanding and the prediction of high impact weather, target what cycle extreme and they impact. So then develop improved, increasingly objective method to balance investment across the weather information value chain. So this is the things based on this in the last, after this report published in the last 2 years till now. So most of research announcement seems align with this recommendation from the, at least from the NOAA Weather Forecast Office, forecast program. So I will not go in all the details here. So at least this is what we talk about research and development, mostly develop of Earth system. This is just to explain what I just said. The infrastructure definitely included the observation system and the high performance computing and also the data dissemination. So some of the action and the impact. So this is mostly highlight the reanalysis and the reforecast, which supports the model evaluation improvement and also high impact weather forecasting and the water cycle extremes. So which is have the high impact. Okay, so then after this, so NOAA actually prioritize the investment by set this readiness level. So in most recent NOAA call for proposal or any discussion, so their readiness level to mark the research as a basic research. So this is readiness level 1 or 2, and in the developing stage 3 to 5. And then demonstrate meaning you already use the forecast model to demonstrate the influence. So it's 6, 8. So then deployment meaning become operational. So all the NOAA research, most of NOAA research announcement recently, we needed to, when we write the proposal, we need to identify what level of the readiness. So they care about this because they want to move from the research to eventually using operation. So this is the one of the big things NOAA actually.
Do you
Yes.
have an idea of if they feel like they have too much of the research and they want to move more to deployment, demonstration, or they, like, is your council, they want to see, or they feel like they're overburdened in one of these and they want to see more of another?
Yeah, this is, yeah, that's a good question. They set this, so each program has the level of expectation. So for instance, for the proposal I write with the research, they ask a minimum 5, so you will reach 5. And for my JTTA, so which is a joint transform this program, they want me at least to go here. So then, I mean, when I write different proposal, I need to assess which level I am, and so then by end of the project, what I do. So if I just use like Wolf model, others I'm perhaps here, but if I use the NOAA operational model for the research, I will be in the develop stage. And then, so based upon the program requirement, if they want you to demonstrate the influence to the operational, so then I needed to go here or here. So this is actually for the from the climate program and the WPO and also all other programs, the announcement, depend on the announcement, so the requirement level of readiness is different. So yeah, we have to look at this. And so then there are some also some of these future engagement. This is definitely not from the science, it's from the management and the communication. So they set up this multiple component to coordinate the talk between the different agency and the components. So I think I just want to quickly just summarize this. So this priority of weather research report is a comprehensive report that focused on the decadal priorities and building upon the existing program. So it is a community consensus that deliver the required information and then take as whole. The balanced investment will be transformative, and it is an urgent call to action. And so there are some impact already there from this report. So you can see this is news from July, and the Biden-Harris administration announced up to $7 million investing in America agenda to improve the weather prediction. And immediately link with this news, there is a NOAA announcement for the multi-university data assimilation consortium. And so this call already closed now, and so it's called for the improve the nation's weather prediction, and because data assimilation is an important component, they need more scientists to jump into this area because community face a shortage of data assimilation scientists. So then they facilitate this multi-university consortium with goal to enhance the data assimilation research and also increase the number of the graduate students to work on data assimilation and eventually can be contribute to the weather forecasting and the Earth system modeling improvement. Okay, so I think there are other news and a call if you pay attention link with this, but just this one is kind of recent one, so I capture my eye, but there are definitely a lot of this NOAA recent opportunity for the research announcement. Many of them link with this report and they talk about the priority. So I think this is all my talk, and thank you for your attention, and I take questions.
My question isn't as related to the talk, but it's been something I've wanted to ask people all day. And that's with Hurricane Otis intensifying so quickly yesterday, what does that do for our thoughts pertaining to future forecasting of these hurricanes? How can we improve hurricanes that we can keep up with the rapid intensification?
I think yeah, that's a good question. NOAA actually, since Hurricane Katrina, so NOAA built this HFIP called the Hurricane Forecast Improvement Program. So there are proposal call, and I was awarded twice, and I recently I didn't write that one, but I involved. So the major research seems to improve the rapid intensification of the hurricane. So I think many of the NOAA research require us to use the NOAA operational model. So we use HWolf, some other people use the GFS. And so there are two things we do. The one thing is people work on the research to understand what's the mechanism which actually need the rapid intensification. And then other people work on use model improvement or data simulation to improve the forecast. And so for the HFIP and also the NOAA JTTA project, so they require us to have the component to do research to operation. So it's all our capability, how we can make the better forecasting. I think we are far beyond the accuracy now, but I think we move to that direction. And some of the satellite observation and also the field campaign, like we recently involved as NASA, CPEX series, and also other. So maybe you involved some previous like aerosol influence, all these things. It's all related.
Yeah, so I have a question for you. So I wrote down one of the priority areas. It says that it wants to increase efforts to advance predictive capabilities for fire weather and air quality, better inform the public during wildfire events and hazardous air pollution episodes. And I'm wondering if, I don't know if you know the answer to this question, maybe someone in this audience does. What tool are like NOAA predictors using to forecast like PM 2.5 from wildfires? Because I'm kind of off in the air chemistry, geochem land where we're doing all these very specific things to understand like how things get oxidized in fire plumes and how we model those. But I'm pretty sure no one's using those tools to actually predict where they're going. So I'm wondering what they're using.
Probably from your country.
Yeah.
There's almost no chemistry.
So what model is it?
So no.
Okay.
Yeah, I think the operational model, I think for the research side, so for instance, we can do large edge simulation, we can do very small scale simulation. But for the operational, they do not now have this type of capability. So because of the computer power, so then they do the more practical way. But I think the NOAA has currently opened door for many of these opportunities.
Yeah,
So
there's a big disconnect there. I feel it just between how
No,
much
that
we know about the
connection.
chemistry of it and what tool we're actually using to tell the public where the wildfire smoke is.
I think if you have the good idea and you know how to transition from one to other, you can work on. At least from our HFIP, so based on this HFIP, we do the landfalling hurricane. So my former postdoc did a lot of this large edge simulation. And from large edge simulation, we see the role, what is inside of the hurricane. And then this was not described in the parameterization of the operational model. So then my postdoc actually worked with me. We actually use this large edge simulation to do the improve the parameterization for the PBL scheme. And then we deliver to NOAA. So this type of things can also, list, so from now they are open the door, and so then as scientists, so we work this side, they work the other side. So there are similar problem, but use a different approach. So then the question now is, how can you bridge so this together? So that is the things we need to think about. So they welcome this expertise because all the things kind of like make link now, and also these things also set the channel. Yeah.
I wanted to ask on the AI front. It did come up
Right.
in one of the slides. I'm curious about the discussion in the committee. It's such a hot topic and there's so much potential. What is the thought on the strategy? Are they talking about replacing characterization? Unified model with AI?
I think this is very good question coming up given the time, because AI has been now start, and even in after this report written. So this discussion never stopped. So recently, in the Nature, so I think the Chinese company Huawei, they published a paper. They built this model called the Penguin model. So then this is an example to use large data sets to try to replace a physical based model. This is related to your question. But I think I read the recent newsletter from ECMWF. So ECMWF Director General Florence Rabia made a statement and comments on that. Because ECMWF now, they have EA, so they use Huawei model, they use other people build a model. EC also has it. So they use AI as forecaster, officially makes a forecast. But in the meantime, they
experimentally. It's
yeah,
not official.
experiment, but there are actually every day has that available. And then they also have the physical based model. So then her statements clearly address ECWF in favor to have this AI and want to continuously develop, but we're not going to give up our physical model. So then it's not say that AI will be replace our physical based model, at least the near term in next 10 years, it's not going to happen. I actually have my personal perspective, but I don't want to share here, but I want to yeah, because the reason is the current AI model is all based on the product from our physical based model and the reanalysis of data simulation results.
Yeah, I was hoping you would share your personal perspective. I mean, one of the things I think that is changing fundamentally right now from any other point in my career is the most innovative and potentially transformative research in the weather prediction business is no longer happening in the academic or government sectors. It's happening in the private sectors. Companies that have enormous resources, but in particular, I mean, from a computer resource perspective, the academic and government sectors have absolutely no hope matching what they're doing.
Yeah.
The fact that the AI-IFS at ECMWF is only 1 day behind in the forecast skill right now. These are systems that were developed in the last, I don't know, several months to a year or two, is quite incredible. And I know it's based on training, based on the Era 5 and that sort of thing, but I would say right now, NOAA needs to be very aware this is going to be enormously disruptive over the next 10 years. I mean, it's going to be a big change in how we do things. The other thing they need to be aware of is, and people were talking about it earlier, my students that work in this area are making enormous amounts of money now in the private sector. They're not going to get that from the academic or the government sector. So, and it's really hard to find people who can do this work. So, just a couple comments. I was curious about your perspectives on where this is all going.
Yeah, I think, Jim, I think this is excellent observation. Definitely it is. It happens. But I think I want to also share your other story. So I remember the time when the Hurricane Irma happened. So we have very ambiguous in terms of so very manifold. So then by the time Panasonic made an announcement saying we are the #1 in the world in terms of the Irma forecast. It is true, but what they did is they blended the product from EC and GFS and so then make it better. It's fine, but in the meantime, so all these private sector, so they derive the product needed support from the government agency. So they're based on this, and also their purpose. Like IBM has a weather forecasting business, even the Chinese company Huawei, they're not intended to build the empire on the weather forecast. What they want is to sell the computer power. So they want the computing market. So around the world, supercomputer #1 usage is defense. For the #2 user is weather forecasting. So the Japanese has a weekend. I think the very notable thing is they do this weather forecasting, and I think the formal University of Maryland assistant professor Takamasa Miyushi, and every year he will jump into the AMS to give the talk about the high resolution central meaning members of ensemble. So yeah, because they have a supercomputer, I think it is true. But so we want the private company doing things different from us. We still need a lot of scientists to work for the government and work in academia to kind of push things forward.
I don't disagree with that. It's a really critical, really national defense issue too. But this is a big change. The US NOAA right now can't even get the HER upgraded. It's been in the works for years. So it's really kind of an interesting situation. There's been, I think, a real stasis over the last 2 or 3 years in the development of moving new models into the pipeline. And in the meantime, you have private sector groups that are, doing things in completely new ways. It's very exciting, but NOAA needs a strategy to think about what the future is going to look like. Because it's going to be very different from the way it looks right now.
I think, this is true. And I think definitely this is an excellent point. This has been discussed because everybody asks for the computer power. But the question now is, NOAA is on one of the government agencies. This really depends on how much the eventually US government wants to invest on this.
Yeah, that's important. But all of this and everything else that the world knows is on Google and AWS and these other systems. Their ability to do way more than just the weather modeling, but boring into everything, economics, the whole 9 yards, is so far beyond anything the government can do. I just see it as being incredibly disruptive.
So
It's going to be a new world in a decade.
That's why it's bring here is the concept of the weather enterprise. It's not just a single.
Yeah.
I really wonder if NOAA will be the go-to source for where you get your data in the future. I mean, I can see the best models getting them from proprietary places that are doing more advanced AI. And the question is the government and NOAA willing to invest to keep up? Or are we going to be in this decentralized place where the best models are run by private companies?
Okay. So I open the student.
Maybe this will change in the next couple of years with this current discussion, but my impression right now is that most of the general public use forecasts that are not generated by the National Weather Service from other companies.
Yeah, that is true.
My impression is that those forecasts are worse currently than like.
Yeah, that is true. I think back to the question, when we have weather channel, whether we should have NOAA. Because I think NOAA's mission is produce a forecast, but not for everybody. So it's covered. But that's why this information dissemination was put as one of the key things, because NOAA wants to make this information available to public so other private company can really use this information to derive for the decision making, support the business, and also for all the users to use, because NOAA cannot service to everyone. So then I think that's why also the weather-related business is so notable in this country now, around the world. So the many countries, so you have the cell phone or computer. So this becomes a business now. Yeah, because you use,
I feel like the reason is probably just that, like Google, for example, does not pull from the National Weather Service. And most people just Google, what's the weather going to be like? And so, like, is there a method for getting some companies like Google or Apple that are providing those kinds of forecasts?
I think
is there a method towards getting those companies to pull from the National Weather Service?
They are.
Every forecast
is rooted in government data and government modeling. Even the NVIDIA and the Google AI-based stuff are all leveraging off of either ECMWF.
But isn't the end product is not what the National Weather Service is doing now?
It may not be, but it's still critical. That's why it's the weather enterprise. It's lots of things. But what I was saying was to say that these companies are already ahead of us, but that we are seeing a big disruptive transformation in kind of what's going to be happening over the
Well, I
next.
guess my impression is that currently they're behind the National Weather Service's forecast. And I feel like recently I had an experience where I was like, oh, we were trying to plan with a friend and I was like, it's gonna rain this day. And they were like, no, the forecast is sunny. And it turned out that the National Weather Service had the correct forecast. They were
The
looking
Weather
at-
Service forecasts are very good. Yeah.
It just feels like it's kind of, well, yeah, people should be able to get the better forecast.
Well, it's like the website, I've directed people my
Yeah, the
entire
website,
career to try and
yeah.
use the National Weather Service website, and I'll go, I don't know how to use this.
Yeah.
They don't know how to do the watches, the warnings, or the timing of the location. And I think it's just like that dissemination, how you actually get it across. Maybe if they took some notes from people and like, big flashing icon or something, find your weather here. It could go along with it.
Okay, please.
So after this talk and after Jim's comments, as a young scientist in training who likes to use idealized cloud resolving models, if I want to put dog food into my dog's bowl 5-10 years from now, what should I be doing? Like where, do we really need thousands of scientists all using CRMs and just publishing papers? Or do we need other things going on?
Yeah, that's an excellent question. It come up. I would say, so anything we do as a research eventually contributes to the forecast. So even if you do the cloud study, so the cloud is very important component in the model. We need to understand the cloud, and then we can predict better. We also need to describe the cloud better in our computer model. We need people do this research. So even you do the field project with cloud. So this is contributed to the entire climate or the weather prediction, because the reason you do field project is you want to understand better the phenomenon. You collect the data and then you understand better, and also you eventually improve our model. So everybody in this department, you're doing whatever you do will contribute to this goal. So the only thing we need to do our best to do the best to help. That's all. So, and there is nothing you really said, okay, I do this, I will not relevant. It's all relevant.
Great, well, with that, we're running a little over time, so it's going to make our speaker.